Hi everyone and welcome back. Now in today's video we are going to discuss about the refresh functionality in Terraform. Now at this stage we already know that Terraform can go ahead and it reads the configuration that you have defined in the TF file, and based on the configuration it creates the infrastructure and it adds the details associated with it in the state file. Now generally this running infrastructure in any provider can be modified manually and Terraform has no way to stop it. And this is the reason why, in case if the infrastructure is modified manually, Terraform needs to know about it so that it can revert to the original configuration that is part of the desired state. And this is where the refresh functionality comes into picture. So whenever you refresh the overall state, Terraform will go ahead and scan the real world infrastructure and then it will update the state as well. Now, one point that you need to keep a note of is that you will not be using the Terraform refresh command explicitly, primarily because whenever you run Terraform plan or Terraform apply, the refreshing actions are applied automatically. So you don't have to manually do that. So let's do one thing. Let's go ahead and quickly also try it out. Now for today's video, I have a very simple resource block that we have been using since a long time, which is creating the EC2 instance. Now again, you don't have to create the EC2 instance. I am just showing it so that our concepts are better understood. Now from the CLI, after you have initialized, you can run the Terraform apply with auto approve so that the EC2 instance gets created quickly. Now once the instance is created, now if you run the Terraform plan once more, one of the first steps that Terraform plan does is to refresh the infrastructure state. For example, here you see the first thing that it is doing is refreshing the state, and based on the current infrastructure it matches to that of the desired one, and now it states that there have been no changes that have been made to the infrastructure. So at a high level overview, you should know that the refreshing of state is done by Terraform plan. Now, one thing that you have to keep in mind specifically related to the refresh functionality, as we know that the refresh automatically happens, so you don't have to do it manually. But sometimes if you do it manually, this can lead to a little dangerous situation. Let me quickly give you an overview. For example, at this stage, the Terraform plan is showing no changes in the infrastructure. That is completely fine. Now let's assume that you change the provider configuration. Instead of US East 1, I say US West 2. Alright, and I'll save the change. Let's clear the screen. This time, if I'll do a Terraform plan, before we do that, if you look into the Terraform TF state file, it basically shows you the details associated with the instance that is currently running. Now, if you run the Terraform plan, it is now showing that a new EC2 instance needs to be added, primarily because we have changed the region in the provider block and it is no longer able to find our older EC2 instance which was in the US East 1 region. So when you open up the terraform.tf state file, the file is still populated at this stage. So if you change this back to US East 1, I'll save the change. Let's clear the screen. Let's do a Terraform plan. Now it is able to find our EC2 instance and now it states no changes are required. Now let's take a second scenario where we will run the Terraform refresh. So let's change to US to West -2. Alright. Now when you run Terraform refresh, the TF state would get changed. So if I'll do a Terraform refresh here, again, it will not be able to find the infrastructure since we have changed the region in the provider configuration. And now if you see in the Terraform TF state file, it is completely empty. All of your configurations went away. And this is the reason why running the Terraform refresh related commands manually is pretty dangerous. It can remove your entire TF state file. However, we also have the TF state backup that is currently available, which we can make use of. So in fact, let me just copy this and add it here. In the refresh.tf, let me just change it to US East 1. I'll save it. Let's clear the screen. Let's do a Terraform plan once more. And if things are working, it should show no changes in the infrastructure. Alright, as expected. Great. So I hope with this you understood that Terraform refresh related functionality is already performed by plan and apply operation, so you don't have to do it manually. When you do a Terraform plan, the state file is not really modified. So even if the provider region is changed, if you run the refresh explicitly, this can lead you to a dangerous situation where your state is removed. So fortunately, since the backup was available, we were able to revert the changes. And this is also one of the reasons why in many of the remote backends like S3, versioning is also enabled. So in case if your state file gets messed up, you can revert to the earlier version. Now, one more thing that you need to keep a note of is that the Terraform refresh command by itself is deprecated in the newer version of Terraform. And in case if you would like, you can use the refresh only option for the Terraform plan and Terraform apply. However, most of the cases you will not be using that, but still from the exam perspective, this is something that you need to keep a note of. So with this, we'll conclude today's video and make sure that you destroy all the resources that you create for your practicals. Hi everyone and welcome back. Now in today's video we are going to discuss about the authentication configuration specific to the AWS provider. Now at this stage, for our initial demos and practicals as part of the course, to make things simpler, we have been manually hard coding the AWS access and secret keys within the provider block itself within our Terraform configuration file. So here you see we have our access key, we have our secret key. Now although from working perspective this works pretty well, however this is not an optimal solution from security point of view. Many times it has been observed that developers, after they hard code the access secret keys, they commit the code directly to the GitHub repository. Sometimes the repositories are public by itself and the credentials are hence compromised. Even if the repository is private, any other user as part of the Git repo will be able to read your access and secret keys, and if they do anything wrong, the blame will directly come to you because your credentials were used. So it is recommended that you do not include the access and secret keys as part of your provider configuration. Now the question that comes is, if the access and secret keys are removed, how will Terraform connect to AWS and authenticate so that the resources can be created? So fortunately, HashiCorp has given us various other ways in which the authentication can work apart from hard coding the secrets as part of provider. So discussing about what we want to achieve, at the overview, we want our code to run successfully without hard coding the secret in the provider block. For example, this is how the provider block, even if it is defined in this way, things should work successfully well. So the only thing here is provider and we are specifying the region. That's about it. So in idle configuration, this code should work. So in today's video, we are going to look into how we can achieve certain steps through which this kind of a code would work successfully well. Now, one of the alternative ways which is much more better than hard coding the credentials is you specify the config and the credentials files here. So what you do, you add a credentials and the appropriate configuration in a separate file within your workstation, and then you add the location to these files. So even if you commit this specific code, the credential files are not present. They are in a different folder itself. And hence, even if you commit the code, there is nothing secret about it that can be leaked. So this is one approach. However, again here there is an issue, primarily because let's say that there are 10 people who are working with a specific Terraform Git repository. Now every person might have a different location in which they are storing the credentials file. So if the location is different, if you hard code the location path here, this can create issues specifically when larger teams are concerned. So what you'll have to do, you will have to achieve certain level of standardization where all of the team members will use the exact same path, and in the path they will have their own individual credentials. However, again, this is not the best of the approach, primarily because if we look into the earlier configuration, this looks much more sleek. It looks so well maintained and easy that would typically work across all the team members without a need of standardization. So here one important part to remember is that if the shared files that we were discussing, so these one, the shared config file and the shared credential files. So if these lines are not added to the provider block, then Terraform will locate these files at home .aws config and home AWS credentials on Linux and Mac OS. So these are the default locations where Terraform will search for the AWS credentials. And when we discuss about Windows, the path is user profile AWS config. You have a user profile AWS credentials. So now, even if you just specify provider AWS region US East 1, that should do. The credentials, if you have added to this specific path, Terraform will directly take it. Now, one of the important areas that I'll recommend specifically if you're working with Terraform from AWS perspective is to install AWS CLI. So at an overview, AWS CLI allows the customers to manage the resources directly from CLI. For example, if you want to create the EC2 instance in AWS, you do not really have to go through the AWS console, create the EC2 instance manually, etc. From the CLI, you can just add a command and the EC2 instance gets created for you. Now, when you are configuring the AWS CLI, the access and secret keys are also required. So the place where AWS CLI stores the access and secret key is the same location from which Terraform tries to search the credentials from, which is the AWS config and AWS credentials. So this path is the path where AWS CLI, it stores the credentials. So let's directly jump to practical to understand things in more detail. Now for today's video, in the KP Labs Terraform folder, apart from the .terraform which gets created on Terraform init, I have one file called as AWS provider-config.tf. Now within this specific file, we have specified a simple resource of IAM user. So all it does is it creates a AWS user called as KP Labs demo user. That's about it. And within here, as we're discussing, I have specified the access key and the secret key. Now we want to get away with this because of security issues. So let's do one thing. Before we proceed, let's test this code, post which we'll be making some changes and make our code much more secure. Now from our CLI, I'll quickly do a Terraform apply with auto approve so that this can save the time. Alright, so our AWS user is created successfully. Let me also quickly show you this. Where do you find the user? So if you go to the IAM service, in the users here, you have the KP Labs demo user. Alright, so this user got created successfully. Let's go ahead and also destroy the resource that we have created. Great, so the resource is destroyed. Now let's go ahead and remove these specific lines from our provider block. I'll save the change and temporarily I'll just add those lines to a text document so that our access key and secret keys are preserved here. Alright, so this is some random text document that you can create. Now, when you go ahead and try to do a Terraform plan, let's see what happens now. Immediately we got an error stating no valid credential sources for AWS provider found. So now what we can do, we can install the AWS CLI, we can configure the access and secret key as part of the CLI, which will be stored in these default locations that Terraform will try and find the credentials from. So from Google, when you search for AWS CLI, there is a specific page related to installing the CLI package. Now the CLI is available for Linux, Mac OS and Windows, and the installation is pretty straightforward. For example, if you are using the Mac OS, you have a GUI installer. So you can go ahead and download this package file. In fact, when you open this up, you see it gets downloaded. And from here, you can install the CLI. Now, in Windows, also you have a very similar approach. You have the MSI file. You can just open this up and the MSI file gets downloaded. You can open this up and the AWS CLI can get installed. Again, there are multiple other ways in case if you'd like, you have command line and other approaches. So for Windows, let me quickly show you. So I'll just open up the MSI. You have a simple setup. Let's go ahead and install the AWS CLI here. Great, and our AWS CLI is installed. Now you can open up the terminal once again after the CLI gets installed. To verify if it is successful, you can just type AWS and you should see the basic help related details here. So this means AWS CLI is installed successfully. So the next part is you have to run the AWS configure command And within here, you can add the access key and secret key. So we had stored the access and secret key in a text document. Let's copy this. I'll add it here. Let's also copy this. I'll add it here. And you can also specify the region if you'd like. And I'll save the change. Alright. So now what AWS CLI has done is that it has stored these credentials to a specific file. And which file it has stored? It is this specific location that we were discussing. In case if it is Linux and Mac, it is your home directory .aws config and home directory .aws credentials, and similar for Windows. Now let me quickly show you where do you find this in Windows. So in C drive, if I go to users, you have .aws here. So let's open up the .aws. You see there are two files. So even in Linux and Mac OS, in the .aws folder, you will have these two files. And inside these two files are the credentials stored. For example, if I'll quickly open this up with Notepad, you see this is where your credentials are stored. And if you do not mention any credentials as part of your provider block in Terraform, these are the files that Terraform will look as default. So once this is set, let's clear the screen and let's try to run the Terraform plan once again. Let's see what happens. You see this time it is working. You did not get an error. And if you want to confirm if things are working as expected, you can just do a Terraform apply with auto approve, and ideally the resources should be created for you. And you see our resource is successfully created. So now with this approach, even if you commit the code publicly, it does not really matter, primarily because the credentials are not present at all. Now before we conclude, I also wanted to show you details specifically related to the AWS provider. Now here we were discussing about few ways in which we can achieve authentication as part of AWS provider. For example, we were discussing about this approach where access and secret keys were used. Along with that, you can also make use of environment variables if you like. So you export certain environment variables like access key, secret key within your CLI, and this approach will also work. Along with that, as we're discussing, you can make use of shared config files and shared credentials files approach as well, which also works. If you do not specify this, then the .aws credentials and config files will be taken by default. Apart from that, there are a lot of other ways. For example, you can assume a IAM role. So you have role, ARN, session, etc. This is also quite useful. Now, since this is not a AWS specific course of Terraform, we are not going into too much detail, but the things that we are discussing as part of today's video is the standard approach which you will generally see in production environment workstations for the users who are actively working with Terraform. But anyways, in case if you'd like to dig deep down, you can also refer to the AWS provider documentation if you'd like. Now, generally the AWS CLI based approach is not only beneficial for the current use case, but specifically when you have some kind of a single sign-on solution, maybe Okta, maybe AWS SSO, this is where AWS CLI also helps. And this is the reason why it is generally recommended that if you're working with AWS, use the AWS CLI for storing the credentials. Alright, so that's a very high level overview about the authentication configuration. Now one more thing that I wanted to discuss before we conclude the video is that this is relatively a newer video after the course was launched. So earlier we had a similar video at a later part of the course in the security section, but I decided that it is better to add it in the initial section of the course itself so that everyone can start to write a code which is much more secure. Sometimes we have seen students, they directly copy paste the entire code along with the credentials over here. So they'll paste the entire code in the Q&A section stating that some things are not working or Terraform code is giving an error. So then as an instructor, we have to remove the question primarily because the access and secret keys are already leaked. And then we have to message with the user, we have to coordinate them to deactivate the key, generate new set of keys and so on. So in the initial part of the course itself, I thought that it will be better if we remove the keys here. But in the first few videos, we decided that we'll use the key-based approach so that we understand the disadvantages that this approach provides. So in the later videos, you might still see that many of the videos might have this, primarily because this video of authentication configuration is relatively new video compared to others. So in case if you still see the access and secret key in the other videos, you can simply remove them, primarily because the AWS CLI is already configured in your system. So that's a high level overview, and with this we'll conclude today's video. Hey everyone, and welcome back. So till now we have been doing some basic things with Terraform, like creating servers across multiple providers like AWS, DigitalOcean, destroying servers, as well as looking into some of the basic aspects of Terraform. So till now I hope you know on how easy it is to get going with Terraform. Now, before we go ahead and discuss in more detail about various features that Terraform offers, I would now like to reiterate some of the important aspects of course specifically related to the lecture format. So let's get started. Now, one important part to remember is that we tend to use different folder for each practical that we do in the course. So using different folders allows us to be more systematic and also allows us to easily revisit the older practicals that we might have done. So this can be better explained with this table where you have three lecture name. Let's assume you have first lecture name as create first EC2 instance, tainting resource and conditional expression. So each one of the Terraform code associated with this practical will be in three different folders. So you have folder 1, folder 2, folder 3, and each one will be associated with a specific lecture name. Again, the folder name are just for the example. You can have a proper folder name which are directly linked with the lecture names. So let me quickly show you that from the Windows Explorer. So from here you see that there are multiple folders that are available, and each one has a unique name like dynamic block, data sources, count parameter, conditional expression, and so on. So let's say tomorrow I want to review the code of conditional expression. All I have to do is I have to go into the conditional expression folder, and I have all the necessary TF files that are available over here. So this becomes much more easier, and I will really recommend you to follow this specific approach where you have a different folder for each practical, and each folder will have its own files that you can later revisit in case if you want to revise it. Great. So this is one important format that we need to know. Second important aspect is that you can also find the appropriate source code from the GitHub. This is something that we have discussed earlier. However, just wanted to reiterate one more time. So all of our code which we have done in the practical is arranged within our GitHub repository according to the sections that are matched to the domains that are part of the course. And every section within the GitHub has easy readme file for quick navigation. Now, in fact, let me quickly show you this. So this is our Terraform course, and you see that there are multiple lectures that are available over here. Again, the navigation will be little different because I am looking into it from an instructor point of view. Now, initially what we had done was in the initial lectures at the start of the course, I had included the links. If you see, I had directly included the links of our repository. So you would see you directly have the link to the practical resource that we had done after the lecture. So this was just for ease of use. However, once you progress, we do not really add the practical resource after every lecture. So what is assumed is you go to our Terraform beginner to advanced GitHub page that I had shared in the start of the course, and here we have multiple sections that are available. Let's quickly look into one of the section. So one of the section here is read, generate and modify configuration, and the same thing that you can see over here, you have read, generate and modify configuration. So you can quickly navigate based on the section name. So once I click on this specific section, you will see that you have a nice readme file, and each readme file basically has the name of the video that you need to refer. So for example, one of the lecture name is understanding attribute and output values, And within here, you have one of the links, which is understanding attributes and output values. So when you click over here, you can directly find the exact configuration that we had used within our specific practical. So this is much more easier way to go ahead and explore things. Now for certain practicals over here, you will see that there are multiple files, like you have vars demo.tf, you have variables.tf, and in that case both of the files are part of the same page, so you can directly copy the first one and you can also copy the second one from the GitHub page directly. Now the third very important pointer is always destroy the resource after practical. So we have already looked into how we can destroy the Terraform resource. So you can run the Terraform destroy command, which will go ahead and destroy the resource for you. So after you have done your trial and error, after you have completed the entire practical, make sure that you destroy the resource before moving to the next practical. Otherwise it will become difficult, because even if you forgot to do a Terraform destroy at the end of the month, you will get a bill associated with the resource that you had created. So this is one important part. Now Terraform destroy becomes much more easier if you are maintaining separate folder for each practical, and this is one of the precise reason why we had done this approach. Great. So that's the high level overview about some of the important format that we'll be following throughout the course. So with this, we'll conclude this video and let's go ahead and begin understanding some of the interesting aspects of Terraform. Hi everyone and welcome back. Now in today's video, we are going to discuss about the learning scope related to the AWS services for this Terraform course. Now one thing that we need to keep a note of is that when we discuss about AWS, it has more than 200 services related to wide variety of categories that are available. Now let me also quickly show you this. So if you look into the services that AWS has, so if I'll go to AWS services, you see AWS has so many services that are available. Now, when we say that as part of this Terraform course, we are going to make use of AWS for our practicals. So this sometimes it leads to confusion. Sometimes people assume that we are going to cover all of the services that AWS offers and we are going to look into it from integration point of view with Terraform. So this is not the primary aim. Remember that the primary aim of this course is to master the core concepts of Terraform. This is the main aim, and after you master the core concepts of Terraform, you will be able to get certified with a great score. Now, as we know that Terraform is an infrastructure as code tool. So if you want to learn Terraform, you need to use Terraform to create some kind of an infrastructure. Now, where you will create infrastructure? Will you use AWS? Will you use Azure, GCP, and so on? There are hundreds of providers that are available on which you can create an infrastructure. And this is the reason why, to keep it simple, we are taking an example of one of the most popular cloud provider in the industry at this stage, which is AWS. Now, when we say that we are going to make use of AWS for our practicals, what does that mean? Are we going to learn about the deep integration about AWS services and how we can write the complex Terraform code for that? The answer is no. That is not the primary aim. Throughout the course, we are going to use very basic AWS services to demonstrate the Terraform concept. So these set of services you will be using not only in AWS but any other cloud provider that you will be working with in your organization. These set of services will be common. For example, one of the common services that you will be using is the virtual machine. In all of the cloud providers, you will be launching some kind of a server where your application will be hosted. So this is the reason why virtual machine, which is the EC2 service in AWS, is one of the common ones that we'll be using for our practical. Second one is the firewall. In AWS, it is referred to as a security group. Again, this is one of the common features that we will be using to demonstrate wide variety of Terraform concepts. Third is we are going to make use of AWS users. For example, we are going to demonstrate various Terraform concepts, and for that we'll create some AWS users. And fourth primary one is IP address. So we are going to create a bunch of elastic IP or a public IP address in AWS through Terraform code, and we'll be modifying that code to include some complex functions, etc., to demonstrate wide variety of features. So throughout this course, these are the four primary areas that we will be using. Now, one part that we need to keep a note of is that occasionally for a video or two, as and when it is required, we might cover one or more AWS services apart from this for a very specific use cases. However, these four are the primary ones. Now, one part that we need to keep a note of is that we have more than 100,000 students from wide variety of backgrounds who are learning Terraform from our course. So when you have so many students who are learning Terraform, everyone will have a different background. For example, some might be AWS professional who are working with AWS from past many years. We have so many students who are not aware about AWS. They are from Azure GCP background. So if you ask them about Azure GCP, they are like pros. We have so many students who are in colleges who have very limited knowledge about cloud and AWS as well as Azure GCP, etc. So when you have students from wide variety of backgrounds, we try to align everyone in the same page by also covering the basic of AWS services that we are going to use throughout the course. For example, let's take a consideration of firewall. Now, let's say that we have a video where we create firewall rules through Terraform. Now, if we have some college going student who has no idea about what firewall is, so this becomes a little bit of confusion. Or let's say that we have some students from different cloud provider background who are aware about firewall, but they do not really know what security group is. Security group is nothing but a virtual firewall in AWS. So this missing knowledge sometimes create issues in learning Terraform concepts. So what we try to do, since we are primarily only going to cover 4 features of AWS in our course, we are also going to have a video or two that demonstrates what the feature is all about. For example, in the course you will see a video associated which explains the basics of firewall, and we also do some practicals related to the firewall in AWS. So you'll see a video or two related to that, and it is only once. After that, in many of the videos, we cover the security group related Terraform configuration to demonstrate wide variety of concepts. Now that becomes simple since we have already covered about the firewall and security group in this course itself. Otherwise, what will happen is student will have to go to YouTube, understand what a firewall is, understand what a security group is, and so on. So instead of going through multiple set of videos across multiple instructors, we try to keep it simple where everything is discussed in the same course. So taking an example of a video where we create firewall rules through Terraform. So before we start writing firewall rules through Terraform, you will see that we first cover the basics of firewalls in AWS, where we discuss the basic of the firewall and also about the firewall features that AWS provides. Then we have a small practical where we create firewall rules through the AWS GUI console so that the concept is very well understood. And then we start with creating firewall rules through Terraform. So this way things become much more simpler and you don't really have to hop around multiple videos across YouTube to understand the basics of firewall and so on. So this also allows all of our students from different background to stay in the course, understand things in a better way and focus on learning Terraform. Now in this case, let's assume that you are from AWS background. You already know about the firewalls. So in such cases, you can mark these video as completed without watching it. You can skip the first 2 videos. You can directly jump to the video number 3 where we create the firewall rules through Terraform. Alright. So this is one thing that I wanted to share. Otherwise, sometimes what happens is if students have not gone through this video and suddenly they come across video where we are learning on how to create firewall rules through the GUI console. So then the question that comes is this a Terraform course or is this a AWS course? And this is the specific reason why I have created the video to avoid any sort of confusion here. Great. So I hope with this you understood the high level learning scope that we are aiming as part of this video course, and with this we'll conclude this video. Hi everyone and welcome back. Now in today's video we are going to discuss about the basics of firewall, and we are also going to look into the firewall offering that AWS provides. Now before we go ahead and look into what firewall is all about, it is important for us to understand the concept of ports. At an overview, a port, it acts as an endpoint of communication to identify a given application or process in an operating system. It can be Windows, it can be Linux, and so on. So again, this is a little confusing definition. So let's understand this from a graphical point of view. Now, let's assume that you have a server with an IP address of 1.2.3.4 and you also have some users across the internet that aims to connect to the server. Now this server has certain softwares that are running. For example, you have a SSH related software, you have a HTTP related software required to host websites and so on. Now, one thing that you have to keep a note of is that whenever a client wants to communicate to a specific software associated with a server, this software or this process needs to open a port. For example, when SSH related packages are installed in the server, it creates a port opening in the port of 22. Similarly, if HTTP related softwares are installed, for example Apache or Nginx, it also creates an opening on port 80. So whenever user wants to directly connect to these specific processes or specific software, they can connect to the server IP followed by the port, which is port 22 or port 80. Alright, so I hope with this it makes a little better sense. Now let's do one thing. Before we proceed further, let me quickly show you on how exactly this looks like, post which we'll be discussing about the firewalls. Now for today's demo, I have a EC2 instance that is running called as website-ec2, and there is a website also hosted on top of this. So let's quickly verify this. So I'll copy the public IP of the EC2 instance, and from a different tab, I'll add the public IP, and as expected, we are getting a simple welcome to Nginx page. So some kind of a website is working from this specific server. Now, when we connect to this server, again note that this is a demo video. Our aim is to understand the concept as part of today's video. Now, when I connect to this specific server, in fact, let me switch to the root user. Now, as we were discussing, that whenever some softwares like SSH or HTTP are installed in the server, they create some form of opening through which the client can directly connect to those set of processes. Now, if you want to see what are the openings that are created by the software that are running in your server, you can run the netstat ntlp command, and here you see that you have one opening of 80 and second opening of 22. So this opening that you see, you can also refer to them as a port. So you have a port of 80, you have a port of 22 that is running. You can also see associated with port 80 what is the software. So here you have a Nginx software that has created a port of 80, or to be more precise, Nginx software has binded itself to port 80. You have SSH software that has binded itself to port 22. So now whenever you connect to the server, for example, this is the public IP address of the server. Whenever you connect to the server, for example, let's say that this server, as we know, it can have multiple set of softwares that are running. So if you want to connect to the server, you can also specify the port. So if I copy the public IP and I can specify the port of 80, where we know that our Nginx software, which is responsible for hosting the website, is running. So when you add a port of 80, you will see welcome to Nginx page. Now generally in browser, automatically whenever you type a IP address, the browser automatically adds a port for you. So this is the reason why you don't have to worry. But if you use something like this, you specify the port, again you see the website is working perfectly well. However, this time instead of port 80, if I try port of 22, you say site cannot be reached, because port of 22, as we know, is associated with the SSH software, and SSH is used to connect to the server through the terminal. It is not responsible for hosting the website, and this is the reason why things will not work. If you add a port of 22, if you change it back to 80, things are working. Great. So I hope with this you understood the basics of port. Now, one more thing that I wanted to show you, in fact, just for simplicity for today's demo, let's install a software of VSFTPD. Alright, I'll quickly start this specific service. Now, if you'll quickly look into the port that are open, you see there is one more port that is open, which is 21 associated with the VSFTPD. Now, generally, whenever you install some kind of a software, SSH, VSFTPD, Nginx, the configuration file has the appropriate port related details so that whenever this service runs, it gets associated with the appropriate port. And since the VSFTPD is associated with a port of 21, from the internet or from other servers, if you want to directly connect to this specific software, you use the server IP plus this port of 21. Great. So that's the basic on what ports are all about. Now comes the important learning for today's video, which is firewall. Now, one thing that I can say is that in any organization that you will be working with, firewall is one of the common area that you will be extensively be configuring for your use cases. If you're working as a developer, if you're working as a DevOps, security engineer, etc., does not matter. Firewall is one of the common things that you will be working with. So let's go ahead and understand what firewall is all about. So at a very high level overview, firewall is a network security system, and through this you can control the incoming and outgoing network traffic to the appropriate server. So let's understand this, where on the right hand side you have a server, and in the server you have two processes that are running. One is the SSH process, second is the HTTP process. Now we already know that whenever you install some kind of a package, if the package has appropriate configuration, it binds itself to a specific port. It can be 22, it can be 80 and so on. So since there are two processes that are running, we are assuming that you have two ports that are open in the server. You have port 22 and you have port 80. Now, you have the user from the internet. Now, the question that comes is, as a security engineer or as a DevOps engineer, you want user to only connect to the server and the HTTPD related process responsible for hosting a website. You do not want user to connect to the SSH related software which allows them to log into the server. So it can happen that a specific server has multiple ports. You only want user to access the 80 port. User should not be able to connect to the 22 port associated with SSH. So in such cases, you can make use of firewall, which acts as a middleman between the user and the server. So at a firewall level, you can create certain set of rules here. For example, here you see that there are two rules. First one is deny connection to the port of 22. Second is allow connection to port of 80. So now, if a user tries to connect to the port of 22 of the server, the request first goes to the firewall. The firewall will inspect the rule sets. Now the rule sets here states deny connection to 22. And this is the reason why this specific connection will be blocked at a firewall level here. Alright, so I hope with this you understood the basic concept of firewall. Now, when we discuss about firewall from AWS perspective, we generally refer to it as a security group. So this security group, it acts as a virtual firewall to the instance to control the inbound and outbound traffic. So here you see, you have a firewall. This firewall has a rule, and based on the rule, it will allow or deny the connection to the EC2 instance. So remember, security group is nothing but firewall in AWS. So let's do one thing before we proceed further. Let's have a quick demo to understand how things work here. Now going back to our demo instance here of website EC2, at this stage, we have confirmed that we are able to open the website, and where this website is hosted, it is hosted in this specific server. Similarly, we were also able to directly connect to the server through the browser. Now, why were these two connections allowed? We know that this website is associated with 80. This connection is associated with 22 and so on. So the reason why both of these are allowed is because the firewall that is associated with the instance or with the server is allowing that. As we have learned, the firewall is also referred to as a security group in AWS. Now, if you look into the security tab, you see there is a security group. So this is what is the firewall. And within here, you see there are certain rules. In fact, you can also open this up. Again, note this is a demo video. So let me quickly show you. Now, if you look into the rule, what does the rule states? It says all traffic allowed from everyone. So this 0000, it means everyone. So everyone will be able to connect to the server is what the firewall rule is saying. Now, let's assume that you remove this firewall rule. Alright, I'll save this. Now let's close this. Let's go back to the server. Let's open the public IP again. Let's add it here. And you see this time the website is not loading. Now sometimes what happens is that even if you have removed a firewall rule and you refresh the page, you will see the website gets loaded primarily because of the cache in the browser. In such cases, you can try from different browser. Anyways, so as soon as we have removed a firewall rule, that means no traffic is allowed. And this is the reason why you see we are also not able to open our website. Similarly, if you want user to just open the website, you can also modify the firewall rule. In fact, let's try this out from demo side. So within here, you see you have to define a port. So I say port of 80, which is associated with website, and I'll say 0000. I'll click on save. Let's refresh this. Immediately here you see we are able to open the website. So at this stage we have allowed only port of 80. This time, if you try to connect to the instance through SSH or directly through browser-based connection, it will not work because firewall is blocking. Alright. So I hope with this you understood what firewall is all about. Now, irrespective of which cloud provider that you are working with, all the firewall will allow or deny the connections. The overall concept is very simple. Let's also take one more example. So currently I am in a DigitalOcean environment. And even in DigitalOcean, if I'll go to networking, you see there is a firewall. Now you can easily create a firewall. You can just give any name. And the overall concept is very simple. You specify the rules here. For example, if I just say custom, you specify which port you want to allow. For example, I want to allow port of 21. Then you specify from which IP address you want to allow, or if you want to allow it from all the IP addresses across the internet. Alright. So all of the configuration related to firewall is pretty common across the provider. Now one thing that we need to understand before we conclude this video is that firewall can control both the inbound and outbound connection to and from the server. For example, we have looked into the inbound connection like allow 80 from the internet, which is 0000. So this is one part. You also have the firewall that acts as an outbound blocker as well. For example, if you are logged into the EC2 instance, this EC2 instance should be able to communicate to whom? Should the EC2 instance be able to communicate to all the servers across the internet, or should the EC2 instance be able to communicate to only one server in the entire internet? So all of this is part of the outbound rules. Again, let's look into it from the demo perspective. Now going back to our website EC2, if you'll open up the firewall here, you see generally in the firewall you will have inbound rules over here and you have the outbound rules over here. Both are present. Similarly, even in the DigitalOcean firewall, you see you have the inbound rules and you have the outbound rules. Inbound rule basically controls who can connect to the server. Alright, so this incoming connection is generally what the inbound rule allows you to control. Outbound rule allows you to control to which remote system the server can connect to. So that's a high level overview, and with this we'll conclude today's video. Hi everyone and welcome back. Now in the earlier video we were discussing about the basics of firewall, and we also looked into one of the firewall offering called as security group in AWS. So today is going to be a practical video where we are going to look into the security group and how we can create one from scratch. Now for today's video, let's do one thing. Before we look into the security group, let's go ahead and quickly launch a EC2 instance. Let's just call it as demo firewall EC2. Now generally whenever you create a EC2 instance, not only in AWS but also in other providers, one of the configurations that you will see apart from key pair is the firewall. So here you see you have a firewall and here you have a security group in the brackets. And from here you can specify what type of traffic you want to allow. So SSH is associated with port 22, HTTPS with port 443 and so on. So at this stage you don't really have to create a security group from scratch, but in case if you'd like, you can do that as well. So let's quickly launch a EC2 instance just for today's demo. We'll keep it very simple at this stage. Now this specific EC2 instance that gets created, you will see associated with it is a security group, and this security group has certain set of inbound rules over here and a certain set of outbound rule. So this is automatically created. In today's video, we'll look into how we can create security group from scratch. Now in order to do that, if you go a bit down in the network and security section, you have a security group, and within here you can create a security group here. Let's just call it as my first SG. Description you can just say firewall, and within here in the inbound rule and in the outbound rule you will have to configure things. So at this stage, outbound rule here is simple, all traffic 0000. This is one important part that you have to ensure. In the inbound rule, you can quickly add a rule. You can say custom TCPs. Now generally what happens is there are some pre-configured options. For example, if I type SSH, the port automatically gets populated for you. So if you say custom TCP, you can specify what port you want. You want 21 and so on. Alright. So I'll just say 22. From where do you want to allow? Whether you want to allow from the entire internet, in such case you can do 0000, or if you want to allow from only one specific IP, say 103.32 and so on. So this is where you can specify one specific IP or the range of IP based on your use case. Now just for simplicity, I'll say 0000, and in the description I'll say allow all traffic to SSH port. Now generally from production environment you should not do this. The port of 22 should ideally be allowed only from your office network, or more better only from VPN. Anyways, so I'll just say this and I'll create the security group over here. Now this security group that you have created, you can associate this security group with the instance that you have created. For example, you can change the security group. So currently we have this security group that was automatically created. I'll click on remove, and then you can specify the security group that you have created, call as my first SZ. You can click on save. Oops, we forgot to click on add security group here, and you can click on save. Alright, so once you have done that, if you look into the security group, this is the rule that you have created. This is one part. Now one more thing that I wanted to show you is that when you copy the public IP address associated with the instance, and from your terminal when you try to ping the IP address, you see you're not getting any response. Why you're not getting any response? It is because of the firewall. Now let's also explore that. So let's assume that we want users to be able to ping to the EC2 instance. So at the firewall stage, you can allow the appropriate rule. So this time let's add a rule. This time the rule will be associated with ICMP. So ICMP is responsible for the ping related activity. I'll say 0000. I'll click on save rules. Now if we clear the screen and if we try to ping again, somehow we are not able to ping. We are still getting a request timed out. So let's understand why. We have primarily made a mistake. Let's verify. Now in a security group, the mistake that we have done is that this ICMP that we have allowed, it is in the outbound. It should be in the inbound, because from the internet we are making a connection to the server. And this is the reason why things are not working. So this will do a delete. Let's click on save. And in the inbound connection, we'll allow it. So I'll say ICMP, I'll say 0000. And now if we do a ping, you see things are working. Alright. So similar to ICMP, you can allow port 80. If you have a website that is running, then you can allow port 80 in the firewall so that everyone will be able to open the website and so on. So this is a very high level overview on how you can create a security group and associate the security group from the EC2 instance. So with this, we'll conclude today's video. Hi everyone and welcome back. Now in today's video, we are going to explore on how we can create the firewall rules in AWS through Terraform. Now the architecture that we have to implement is very simple, where we have to create a firewall, which is the security group in AWS with the following configuration, where the name of the security group here should be Terraform-firewall, and it should have following rules. There are two set of rules. One is the inbound rule, which states allow the port 80 from the internet, which is 0000, and outbound rule states allow all. So this is the architecture based on which you'll have to create the Terraform configuration. So let's get started. Now in AWS, as we know, there are hundreds of services that are available. Now for each services, you have separate set of Terraform resource that is available for you to create. As we know, in AWS, security group is the virtual firewall. So in order to find the appropriate code of Terraform to create the security group, in Google, type Terraform security group. And once you do that, it will take you to the appropriate page which allows you to create the security group. So let's open this up. And within here, you see, you have the resource of AWS security group. And if you go a bit down, HashiCorp has also given a set of examples. So let's do one thing. Just for simplicity, let's just copy this. And within our KP Labs Terraform folder, I only have the .terraform folder over here, which gets created when you do a Terraform init. The earlier TF files are removed. So let's quickly open this up with the Visual Studio Code. And in our KP Labs Terraform folder, let's create a new file of firewall TF. Let's paste the things that we saw from the example over here. Now, let's go ahead and understand this step by step. So the first thing that we are going to understand is this specific block of AWS_security_group. Alright, so just for simplicity, let's just remove this. We'll be understanding about this in just a moment, but first we'll just take an example of this block. What does this block does? It allows you to create a security group in AWS. Now, when you want to understand about what each one of these part does, there are two approaches in which you can do. First one is that you can read the documentation. For example, here they'll specify what exactly each part does. Second way is you can try to create the resource from the console. This way also you'll get a better idea. For example, whenever you create a security group in AWS, here you see it asks you for the security group name. It asks you for the description. It asks you for the VPC. Similarly, you have the name, you have the description, you have the VPC, and so on. So if you know how to create a specific resource in any cloud provider through the console, you will be able to easily create that resource through Terraform as well. Now, at this stage, we know that the name of the security group that we want is Terraform-firewall. So this first part, let's add it here. I'll say Terraform-firewall. Alright, so this is the name. Then you have the description. You can just say managed from Terraform. And then you have the VPC ID. Now, if you look into the documentation, you can verify whether each one of them is mandatory to mention or it is optional. For example, description here, it states optional. So it is not necessary that you need to add it as part of your Terraform block. Similarly, if you see the VPC ID, also this is optional. So what this means, if you want, you can remove this part and still the security group or still the resource will be created for you. Alright. So just for simplicity, let's also remove the tags. We only have these two parts. If you want, you can also remove the description. It will still work, but just to make things a little better, I have added a description. I'll save the change. Now from our folder, let's go ahead and open up the terminal. I already have done the Terraform init. In case if you don't have .terraform folder, you can run that. So I'll directly start with Terraform plan command. Before we do that, you can also add the provider related configuration. I'll say provider of AWS and you can specify region of US East 1 or whatever region where you want to create this resource into. So I'll save this and now let's do a Terraform plan. And you see things are working. It states one to add. So I'll go ahead and do a Terraform apply with auto approve. And our resource is successfully created. Now within our AWS console, let's go to the security group. In fact, if you are in the instances section, there is an option of security groups here. Alright, now you see there in the North Virginia region that we have used, you have a new security group called as Terraform-firewall that is created. Now, if you look into this security group, at this stage, there are no inbound rules over here. There are no outbound rules over here. So inbound rule needs to be created. If you are doing it through console, it is very simple. You can directly add a rule based on what configuration that you'd like. So what you want to replicate this, but from Terraform. So let's explore that. Now coming back to the documentation of the AWS security group. At this stage, we learned about this first part. What it does is simply it creates a security group without any rules. However, security group without rule makes little sense. So now the next part is to add the rules. So this is where the next set of block comes into picture. Now there are two important areas here. One is the ingress rule. Second is the egress rule. Now generally in security group, you have two set of rules. One is the inbound rules. Second is the outbound rules. So ingress is referred to as inbound. Egress is referred to as outbound. Alright, this is one thing that you need to remember. In fact, even if you try to create security group through other infrastructure as code solution like CloudFormation, even in here, you have similar naming convention. So you have security group egress, which is outbound, and ingress, which is inbound. Alright. So this is one part that you need to remember. So here what they have done, they have created multiple set of inbound rules here. So you have two set of inbound rules. You have two set of outbound rules. Let's take example of one inbound rule here. Let's copy this. I'll add it here. And one example of egress rule, which is the outbound rule, I'll copy this. I'll add here. Now, one thing that you need to remember is that this is a separate resource. For example, this specific resource that we are discussing, which is the main resource of this document page, this just creates a security group. For security group rules, you have one more resource type of AWS VPC security group followed by either inbound or outbound rules. So if you type this in documentation, or you can also get it from here, let's search it. So in the documentation of Terraform, you have a separate page associated with the inbound and outbound rule. So you have a separate resource type of inbound rule. Here you see it states manages the inbound rule for security group. And here you can get all the details about it. Sometimes what happens is HashiCorp is known to change the documentation occasionally. So today they have mentioned this example here. Tomorrow for AWS security group resource, they'll just specify this. They'll not specify the bottom part. It can happen. So this is the reason why it is important for us to understand that there are different resource types are managed in different page. So even if the documentation are changed, you can easily search it through the filters here. Anyways, coming back to our practical, as we know, you have the AWS VPC security group. This remains to be the same. Then you have the ingress rule and then you have the egress rule. The name is fine. In fact, this is a bigger name, that is fine. So we have to understand this part here and this part here. Now, whenever you create a new inbound rule, let's try it out. Whenever you create a new rule, there are certain things that you'll have to specify. For example, you'll have to specify the port. For example, you want to allow SSH port or you want to allow port 80. What exactly you want to allow in firewall is something that you'll have to specify. Then you will have to specify the source from which IP address you want to allow. You want to allow from all the IP address, or you want to allow maybe from only my IP address and so on. And then you have the description associated with this rule. Similarly, here also you'll have to add the same thing. You have to specify the port from which port you want to allow. If you look into this specific diagram, we want to allow port 80 from 0000. So what you can do, you can say port 80 in both the places of from port and to port, and in the CIDR IPv4, you can say 0000/0. Alright, we'll save this. Similarly, for the outbound rule also, let's verify that. In the outbound rules also here, whenever you create a rule, the page looks very similar. Now, outbound rule we want to allow all. So the server should be able to connect externally to all the resources. So within here, the CIDR IPv4 block is 0000. That is completely fine. And in the IP underscore protocol, because in the ingress block, IP underscore protocol is TCP. You have other protocol like UDP, etc. also that you can use. So in here, you have -1. There is also a description which is semantically equivalent to all ports. So this looks good. We'll go ahead and we'll save the change. I'll clear the screen when you do a Terraform plan. This time, you see, you have two to add, which is the inbound rule and the outbound rule. So let's go ahead and apply both of them. I'll say Terraform apply auto approve. Great. So now if we explore our Terraform firewall security group, you will see that there is one inbound rule for port of 80. You see the source is 0000, and also one outbound rule which allows all traffic for all protocol, all port on destination of 0000. So I hope with this you understood what this -1 or -1 does. So if you do not add this, you can specify the port manually, similar to what we have done. Now, before we conclude, one more thing that I wanted to show you, otherwise this will lead to a small confusion, is what exactly this means. Because you have from underscore port and to underscore port. Now, generally in AWS, whenever you add a new rule, in fact, let me quickly show you this. There is a specific option related to port range where you can specify, for example, port 21. This is one easy thing to understand. But what happens if a customer has a requirement where they want to add a range of port? For example, a customer wants to add a port ranging from 80 to 100. So in such case, it is not practically possible to first add a rule of 80, then add one more rule of 81, then add one more rule of 82 and so on. This is cumbersome and not required. So in such case, you can also specify a range of port over here. For example, we can say 80 to 100. Alright. So this is the port range. I can add from 0000. So this is what this from port and to port allows us to do. Now, when we have defined the range, the first part over here is the from port and the second part over here is the to port. Alright. Let's cancel this so that we don't make any manual changes. So the first part is from port, the to port you can say 100. Just for simplicity, I'll save the change. Coming back to the terminal, let's do a Terraform apply with auto approve. So once the modification has been completed, let's refresh, and our security group over here, if you'll see, the port range here is 80 to 100. Alright, so I hope with this you also understood the from port and to port. Now in the entire code, there is only one thing that we have not yet explored, which is this specific one, which is the security group ID. Now one thing that we have learned is that the security group and the security group rules are two separate parts. So within the security group ID, we have referenced here. So you have AWS security group here, which is this specific resource, and the name is allow underscore TLS, which is this .id. So at a very high level overview, this basically means that all of these rules that are created will be added to this specific security group with the name of allow underscore TLS, because here we have mentioned allow underscore TLS. Alright. Now we'll be discussing about this in great detail at a later part of the course. But at this stage, just note that ultimately all of these rules will get added here. Now, just for simplicity, let me show you one more thing. I have a default security group also available. Now, if I specify the ID over here to that of the default security group, let's just specify the default security group ID. I'll save the change. So now what will happen is this specific rule will be added to this specific security group. Now, before we do that, let's verify what rule this security group has. At this stage, it does not have a rule related to port 80. So let's save the change. Let's clear the screen. Let's do a Terraform plan. let's see what Terraform is trying to do. So there is one to add and one to destroy. That is fine. Let's do a Terraform apply with auto approve. Great. So now that we have removed this specific resource reference from here, what will happen is this rule that was added to this security group, first part is this rule will be removed and this rule will be added to the default security group. So if you have to verify, let's refresh this. You see this time for the default security group, you have port range of 80 to 100. And our Terraform firewall security group, if you will see, it has no inbound rule. There will still be one outbound rule here. Great. So I hope with this you understood on how you can create the security group rules in Terraform. Now from what we have seen, overall things are quite simple. First time it takes a little amount of time to understand it. Once you have understood, it becomes much more simpler on a longer run. So that's an overview, and with this we'll conclude this video. Hi everyone and welcome back. Now in today's video we are going to look into how we can deal with the documentation code updates in Terraform. So whenever you're working with Terraform from a long time, one thing that you will occasionally notice is that there are some changes in the documentation whenever the newer version of providers are released. For example, let's take a use case of the security group resource. Now, if you look into the newer approach of security group, first you create a security group here and then using the VPC security group rules, you create certain set of rule and then you associate it with the security group that you have created. This is a newer approach where there are two different resource types that are being used to achieve one part. Similarly, in the older approach, you had the AWS security group, so the resource type remains to be the same, and in the same resource, you would specify a set of ingress and egress rules. So both of them allows you to achieve the same thing. However, one on the left is the newer approach, one on the right is the older approach. Now generally whenever you're working with Terraform, you don't have to remember anything by heart. So I have been working with Terraform since past many years. If you ask me to create a resource without looking into the documentation, I'll not be able to do. Everything you have to take from the documentation, and HashiCorp has made a great job to create a right set of extensive documentation. So now whenever HashiCorp makes changes to the documentation, sometimes the example code also changes and this can make things difficult. Let me quickly show you. Now before we look into the documentation part, let's look into the example of security group that we were referencing to. As we were discussing, in the newer approach of creation of security group, first you create a security group using the AWS security group resource type, and then once the security group is created, you can use the AWS VPC security group ingress rule and AWS VPC security group egress rule to create the inbound and outbound rules associated with this security group accordingly. This is the newer approach and a recommended one. Now just to revise, if you look into the AWS security group over here, in the documentation also if you look into the basic usage, you create a security group and you create the rules using the separate resource type. So this works perfectly well. However, in the earlier version of the providers, the approach was a little different. For example, if you look into the older approach, this is how it looked like, where you have a AWS security group and inside this resource itself, you would specify ingress and you would specify egress. So you don't have to mention multiple set of resource types to achieve the creation of security group and its associated rules. Now, one thing that you need to keep a note of is that although this kind of an approach is not mentioned in this specific documentation, so earlier it was part of this example usage, but as part of the newer provider, the HashiCorp has added the newer recommended way of achieving this. So this does not really mean that the older approach will not work. The older approach will still work. In fact, let me quickly show you this. Now from the CLI, in fact, let's do one thing. Again, this is a demo video. I just wanted to show you one thing. So this newer approach, this is something that we have been using. I'll just name it to BAK so that this does not get used when we do a Terraform plan. Anyways, Now I'll quickly do a Terraform init so that the newer version of provider gets downloaded, whatever the newer version it is as of today, which is 5.38. In your case, it might be different. Alright, so this is the latest version of the provider plugins that are downloaded. So now when I do a Terraform plan, let's verify if the older way of writing code still works. And as expected, things are working. If you do a Terraform apply with auto approve, you see a security group has been created successfully. And if you look into the security group that got created with the name of allowed TLS, in the inbound rule, you will see that there is one rule of HTTPS port 443 from 1077.32.50, which is the same thing over here. And you also have a egress rule. Great. So from here we have learnt that there can be multiple different ways in which you can create a specific resource. It can happen that when you go ahead and look into some of the legacy Terraform code, you will not be able to match it with the example usage that you will see, and this can lead to confusion. And this is the reason why we are having this specific video. Now, one of the great things that you will see in the documentation, and this is why I really like the way HashiCorp creates the documentation page, is that there is a specific option related to the provider version. For example, at this stage, the version is 5.38.0. However, in case if you'd like, you can also switch to the older version. In fact, they have also given a note related to the things that we were discussing. So, in case if you'd like to see the sample code usage related to the previous provider version, so you have great set of options available. So this is 5.38.0. In fact, this was published just 18 hours ago. Let's look into previous version. So there are various versions available. You can go back. Let's look into the one which is 5.31.0. Now, if you'll see in the example usage, this is a different usage similar to the code block that we were looking, where in the security group resource itself, you specify the ingress and the egress. Alright. Now, as we were discussing, sometimes when you look into the legacy code that someone has written in your organization and has left, you will not be able to match the latest provider documentation. So in such case, you can look into the previous provider documentation associated with whatever provider, in case if you want to reference to the earlier code that you have found. So let's look into some of the pointers that you need to keep a note of. First one is that just because a better approach is recommended by the HashiCorp does not always mean that the older approach will stop working. Similar to what we have seen in today's video, the older provider based approach that we saw in the example usage is still perfectly working with the newer provider plugins. Second pointer is that organizations can continue to use the approach that suits best in its environment. So it's not that if there are some changes in the newer and the latest provider plugins, organization will go ahead and modify all of the resource code. This is something that does not happen. Many times organization will stick to a very specific Terraform and the provider version because all of the code is working perfectly and they are happy with that. In such case, there is no need to upgrade to the latest version unless and until it is required. For example, let's say you are using Windows 10. You are perfectly happy with that. All of your applications are working the way you want. So unnecessarily, why will you switch to Windows 11? If everything is working in Windows 10, you will not switch. Similarly, if everything and all the code, everything is working perfectly in a specific version of provider plugin and Terraform, organization will continue to use that. It ensures stability. Along with that, as we were discussing in the HashiCorp documentation, you can always select the older version of the provider and all of the example usage and other details will be changed accordingly based on what was there in the previous versions of the provider. Now, just for simplicity, I'll show you what happens is there is just a small change in the URL. For example, let's say that you are using the latest version. So here you will see that there is a small change in the URL. If you switch to the older version, say 5.29.0, just the part of the URL changes. So this is a very small change, but it is quite important for us to remember. So before we conclude, let's also discuss some of the closing pointers. In fact, we have already discussed. I have added it here so that you can revise it at a later stage. First pointer states that whenever you have a larger enterprises, it becomes difficult to upgrade the code base to the newer approach that the provider recommends. This is something that we have already discussed. So in case if enterprise do not want to switch to the latest version of the provider, they are happy with whatever version their code is working well, they'll stick with that. Unnecessarily, there is no need to upgrade. And this is what the second pointer is all about, where it states that in case if they do not want to upgrade the code, they can stick with the appropriate provider version where everything is working fine for them. So that's a very high level overview on how you can deal with the documentation code updates. Sometimes even for this course you will find, for example, let's say that in the earlier version of the videos we used the older approach that you see on the right. However, when the HashiCorp changed the example usage as part of the documentation, we decided to revise all the videos where the older approach were used, and we decided to recreate the videos using the newer approach. But sometimes what happens is it takes a little amount of time for new videos to be created, edited and uploaded. In such case, you might still see the older version of the code of security group, for an example. Now, as we have learned, this code will still work perfectly, but since you are not able to see it in the documentation, it might create a little bit of confusion. And this is the reason why we have looked into how you can switch to the previous version of provider documentation to understand what a specific code block does that was designed in the earlier provider plugin based approach. So that's an overview, and with this we'll conclude this video.